Hi guys, let's look at the second part of the exercise 7C. This is the second video for us on that exercise. Okay, but before we start, let's quickly revise the property that we've done in the first part of this video, which is if A upon B is given equal to C upon D. So if this is given, then we talked about five properties. The first one said B upon A will be equal to D upon C, which means the reciprocal of this. So this property was called invertendo, which means we are doing inverting or taking the reciprocal. The second one was if I replace the denominator and numerator, so this will be A upon C is equal to B upon D. This was called alternando. The next one we talked about was componendo, where we add 1 to both the sides to get this property, and this was A plus B upon B would be equal to C plus D upon D. This was componendo. The next one was dividendo, where we subtracted 1, so it would come like A minus B upon B is equal to C minus D upon D. This was a dividendo. And then the last one was if we applied componendo and dividendo together, it would give us A plus B upon A minus B would be equal to C plus D upon C minus D. This was componendo and dividendo put together. So this exercise is basically about these five properties. Let's go ahead and solve some more questions using these properties. So the first question that we solve is question number 6, part 2. This is, you can again put a small star on this question, exactly the same as the first part of this question. I notice I need 2 root 2 to be added and 2 root 2 to be subtracted, which means this will come if I apply componendo and dividendo on A upon 2 root 2, and here I'm adding 2 root 3 and subtracting 2 root 3, which means this second term will come if I have A upon 2 root 3. If I apply componendo and dividendo, I will get the second term. If I apply componendo and dividendo on this term, I will get the first term. So let's see what we get. So A is equal to 4 root 6 upon root 2 plus root 3. Let's divide both sides by 2 root 2. When I divide both sides by 2 root 2, I get A upon 2 root 2 is equal to 4 root 6 upon root 2 plus root 3 upon 2 root 2. 2 and root 2 multiplied with root 3. So what we get is A upon 2 root 2 is equal to 2 root 3 upon root 2 plus root 3. Now that we've got this, let's apply componendo and dividendo. So using componendo and dividendo, we get A plus 2 root 2 upon A minus 2 root 2 is equal to 2 root 3 plus root 2 plus root 3 divided by 2 root 3 minus root 2 minus root 3. Let's see what this gives us. This is point number 5 for us. So A plus 2 root 2 upon A minus 2 root 2 would give us 2 root 3 plus root 3. That's 3 root 3 plus root 2. In the denominator, 2 root 3 minus root 3, that is root 3 minus root 2. Let's call this equation 1. Now let's try and bring the second term, which means to do this, we'll have to divide A by 2 root 3. So A is equal to 4 root 6 upon root 2 plus root 3. Let's divide both sides by 2 root 3. Yes, this will give us A upon 2 root 3 is equal to 4 root 6 upon root 2 plus root 3 divided by 2 root 3. 2 root 3 into 1, root 3 into 2. So we get A upon 2 root 3 is equal to 2 root 2 upon root 2 plus root 3. Next, using componendo and dividendo, we get A plus 2 root 3 upon A minus 2 root 3 would be equal to 2 root 2 plus root 2 plus root 3 divided by 2 root 2 minus root 2 minus root 3. which means a plus 2 root 3 upon a minus 2 root 3 will give us 3 root 2 plus root 3 upon 2 root 2 minus root 2, that's root 2 minus root 3. That's our second term. So let's add 1 and 2 because they want us to add. So 1 plus 2 will give us where is 1? Here. Okay. So 3 root 3 root 3 plus root 2 upon root 3 minus root 2 plus 3 root 2 plus root 3 upon root 2 minus root 3. And this is what we need as per the question. A plus 2 root 2 upon a minus 2 root 2 plus a plus 2 root 3 upon a minus 2 root 3. I notice I have the same denominator but with the reverse sign. So let's change the sign in the between these two terms. So we have 3 root 3 plus root 2 upon root 3 minus root 2 minus 3 root 2 plus root 3 upon root 3 minus root 2. So let's take the LCM. This becomes root 3 minus root 2. In the numerator, we get 3 root 3 plus root 2 minus 3 root 2 minus root 3. 3 root 3 minus root 3, that gives us 2 root 3. Root 2 minus 3 root 2 gives us minus 2 root 2. In the denominator, I have root 3 minus root 2. I notice 2 is common, so 2 times root 3 minus root 2 divided by root 3 minus root 2. This gets cancelled and our answer is 2. In fact, if I remember, our answer for the previous question, which was 6 part 1, was also 2. Good. So that brings me to the next question. The next question that we do is question number 7. Question number 7, it says if a plus b plus c plus d, okay, multiplied with something is equal to something into something, prove that a, okay, a is to b is equal to c is to d. Okay, so let's first write it in the fraction form, which means we will have a plus b plus c plus d, and let's take this term together, right? So divided by a plus b minus c minus d, and on the right hand side I have a minus b plus c minus d divided by, let's take this the other side, this is a minus b minus c plus d, right? In case you did not understand this, what I have done is, if p into q is equal to r into s, what I have written this as p upon r is equal to s upon q, right? Divide this by r, divide this by q. That's all I have done, nothing else. Now that we've got this, let's go ahead and apply C and D and see if this works. So applying componendo and dividendo, what we get is a plus b plus c plus d. This is the numerator, plus the denominator a plus b minus c minus d. And in the denominator will be numerator, which is a plus b plus c plus d, minus the denominator, which means the sign of all the elements will change. So negative a, negative b, positive c, positive d. Perfect. Exactly the same for the right hand side, which is a minus b plus c minus d plus a minus b minus c plus d, and in the denominator a minus b plus c minus d, and the sign, since I'm subtracting, the sign of all the elements in the denominator will change. So minus a plus b plus c minus d. Let's see what gets cancelled. Negative c positive c plus d minus d. Negative a positive a plus b minus b. So what we are left with 2 times a plus b, and in the denominator I have 2 times c plus d. Okay, and here minus b, oh no, minus b is there. What gets cancelled? Let's see, minus c and plus c gets cancelled, and minus d and plus d gets cancelled. So we have 2 times a minus b. In the denominator, I have a and negative a gets cancelled, and negative b and plus b gets cancelled. So we have 2 times c minus d. This 2 and 2 gets cancelled, 2 and 2 gets cancelled. So what we are left with is, let's give this step number 4. This gives us a plus b upon c plus d is equal to a minus b upon c minus d. I notice that this is, we can apply componendo and dividendo here only if I bring c plus d in the numerator and I bring a minus b in denominator. So this is using alternando. Alternando is when you want to move the numerator to denominator of the other side, and what we get is a plus b upon a minus b is equal to c plus d upon c minus d. Now again using componendo and dividendo, we get a plus b plus a minus b upon a plus b minus a plus b. When I subtract the sign of both the elements in the denominator change, this is c plus d plus c minus d divided by c plus d minus c plus d. Negative b plus b, negative a plus a, negative d plus d, negative c plus c. This gives me 2a upon 2b is equal to 2c upon 2d. 2 and 2 gets cancelled from both sides, which means a upon b is equal to c upon d. That's what they wanted us to prove. Let's read the question. No, they want us to prove it in the ratio form, so I will have to write my answer in the ratio form. Therefore, a is to b is equal to c is to d. Hence proved. So very interesting question. First, it was in the multiplication form, so we converted it into the fraction form. Next, we applied componendo and dividendo. Next, we applied alternando. Then we applied componendo and dividendo again. So very interesting question. Let's look at the next one. The next one that we are doing is question number 10. It says, if ABC are in continued proportion, prove that something is equal to something. So this is basically a question like what we done in our last exercise as well, where ABC are given in continuous ratio, which means a continuous proportion rather. A is to B is to C. What this gives us is, let A upon B is equal to B upon C is equal to K. Now A is equal to BK, B is equal to CK, which means A is equal to CK square. Now let's substitute these values in the left hand side and right hand side and see if we are able to prove anything. So our left hand side first. Left hand side is A square, which means CK square whole square, plus B square, which is CK whole square, plus C square, which is C square. In the denominator, I have A, which is CK square, plus CK, plus C, the whole square. Let's see if I can take anything common. Let's first square this. This becomes C square K to the power 4. This becomes C square K square plus C square. In the denominator, I noted that C is common in all three elements. So I take C common. What remains inside the bracket is K square plus K plus 1. And everything is to the power 2. Yes, we are squaring everything. So what this gives us is, in the numerator, I noted that C square is common in all the elements. So this is C square times K to the power 4 plus K to the power 2 plus 1. And in the numerator, in the denominator, I get C square K square plus K plus 1 to the power 2. Right, that's correct. C square and C square gets cancelled, which means left hand side is equal to K to the power 4 plus K to the power 2 plus 1 upon K to the power 2 plus K plus 1 whole square. Let's see, I don't think I can do anything more from here, at least now. Let's go ahead and see if I can do something to the right hand side. So I hope you remember, if you need to prove left hand side equal to right hand side, approved method 1, start with left hand side, solve it and bring it equal to right hand side. Approved method number 2, start working with right hand side, solve it and bring it equal to left hand side. Approved method 3, which is work with left hand side, bring it to a value, let's say x, work with right hand side and bring it to the same value x. That's the only 3 approved options. You're not allowed to cross multiply. You're not allowed to bring any element from left hand side to right hand side or vice versa. So let's work with right hand side. So in the right hand side, I have a minus b plus c, which would be ck square minus b, which is ck plus c. In the denominator, I have ck square plus ck plus c. I notice that c is common in the numerator. So this is c, k square minus k plus 1. In the denominator, again I have c common. So that's k square plus k plus 1. C and c gets cancelled. So what I get is k square minus k plus 1 upon k square plus k plus 1. Let me see if I have reached the left hand side. I notice the k square plus k plus 1 is common, but on the left hand side I have the square of it. So let me just multiply both numerator and denominator by k square plus k plus 1. Yes, I'm allowed to multiply and divide the same number to both numerator and denominator because that will not change my fraction. Why am I doing it? Because I notice I have to reach left hand side, and in the left hand side I had square of k square plus k plus 1. So let's go ahead and multiply. So when I multiply, I get k square into k square, that's k to the power 4, k square into k, that's plus k cube, plus k square into 1, that's plus k square. Now negative k into k square, that's negative k cube, negative k into k, that's negative k square, negative k into 1, that's negative k, then plus 1 into k square, that's plus k square, 1 into k, plus 1 into 1, that's 1. In the denominator, I don't need to open the bracket because that's exactly what I need, k square plus k plus 1 whole square. Let's see if anything gets cancelled. K to the power 3, k to the power 3, k to the power 2, k to the power 2, k and k. So what we have in the numerator now is k to the power 4 plus k square plus 1, and in the denominator I have k square plus k plus 1 to the power 2, and this is equal to right hand side. So from 6 and 10, left hand side is equal to right hand side, so hence proved. Perfect. Slightly longish question, but very interesting. Let's look at the next one. The next question that we are doing is question number 11, part 1. It says using properties of proportion, solve for x. So we are not allowed to cross multiply because it's saying use properties of proportion. So number 1, using componendo and dividendo. Let's see what we get. We get x plus 5 plus x minus 16 plus x plus 5 minus x minus 16, that's the numerator, and in the denominator I get x plus 5 plus x minus 16 minus x plus 5 plus x minus 16, right? The sign of both the elements in the denominator changes, and on the right hand side there will be 7 plus 3 upon 7 minus 3. This element gets cancelled and this element gets cancelled. So we have 2 times root x plus 5 upon 2 times root x minus 16 is equal to 7 plus 3, that's 10, 7 minus 3, that's 4, that's 5 upon 2. This 2 and this 2 gets cancelled. So now we are left with root of x plus 5 upon root of x minus 16 is equal to 5 upon 2. Now we need to remove the square sign. So let's go ahead and square both sides. So squaring both sides, let's see what we get. So if I square both sides, we get x plus 5 upon x minus 16 is equal to 5 upon 2 square, which is 25 upon 4. Let's go ahead and cross multiply. When we cross multiply, we get 25x minus 25 into 16, that's 400. Yes, that's 400 is equal to 4x plus 20. Let's bring x on one side, so that's 25x minus 4x is equal to 20 plus 400. That gives me 21x is equal to 420. X is equal to 20. Perfect, that's the value of x. Good. Let's look at the next question. The next question that we do is question number 11, part 3. Again, using properties of proportion, solve for x. So let's go ahead and apply componendo and dividendo once again. So using componendo and dividendo, we get 3x plus 9x square minus 5 plus 3x minus 9x square minus 5, the square root, divided by 3x plus 9x square minus 5 minus 3x plus 9x square minus 5. And here the denominator is 1, that's obvious, which means this is 5 plus 1 upon 5 minus 1. So negative 9x square plus minus 5, the square root, and this gets cancelled. Negative 3x and plus 3x gets cancelled. So what we have here is 3x plus 3x, which is 2 times 3x, and in the denominator we have 2 times the root of 9x square minus 5, and here we have 6 upon 4. 2 and 2 gets cancelled. This is 3, this is 2. Again, let's take the square of both sides. So squaring both sides. Why are we doing it? Because I want to remove the square root sign. Becomes difficult to work with square root sign. Okay, so what we get is 9x square upon 9x square minus 5 is equal to 9 upon 4. Let me reconfirm. 3x whole square, that's 9x square. This is 9x square minus 5 is equal to 9. 3 whole square is 9 upon 4. Okay, I notice 9 is common, so I could remove 9, or let's go ahead and cross multiply. So this is 36x square, 4 into 9, that 36x square is equal to 9 into 9x square, that's 81x square minus 45. Let's bring x square on one side, so 81x square minus 36x square is equal to 45. Yes, I bring 36 here, negative 45 here. So 81 minus 36, that's 45x square is equal to 45, which means x square is equal to 1, which means x could be equal to plus or minus 1. Now, whenever you have a square root sign, let's look at both the answers. If x were negative 1, what would it be? Let's put this. So I will get negative 3 because x is negative 1, plus that will be 9 minus 5, and this will be negative 3 minus 9 minus 5. So this will be negative 3 plus 2, and this will be negative 3 minus 2. Negative 3 plus 2, that gives me negative 1. Yes, and this will be negative 5. This is 1 upon 5. Is that the value that we wanted? No. So let's try plus 1. So if I try plus 1, that will be 3 plus 2 upon 3 minus 2, which will be 5 upon 1, which means negative value is not the correct one. Therefore, x is equal to only 1. So I recommend whenever you get a value, whenever you have a square root sign, you should put the value of x in the question and see if both the values work or not. Good, that brings me to the next question of this exercise, which I do with you, which was a board question in 2007. That's question number 12. It says if x is equal to something, prove 3dx square minus 2ax is equal to 0. Okay. The only thing we know is componendo and dividendo. So because I am using componendo and dividendo because there is plus and minus both. So using componendo and dividendo, we get x plus 1 upon x minus 1. That's correct. The denominator here is 1. This will be a plus 3b plus a minus 3b plus a plus 3b, the square root, minus a minus 3b, the square root of this, divided by a plus 3b plus a minus 3b minus a plus 3b plus a minus 3b. This term gets cancelled, this term gets cancelled. So what we have is x plus 1 upon x minus 1 is equal to 2 times a plus 3b upon 2 times a minus 3b. 2 and 2 gets cancelled. In the answer that I need, I have an x square, which means I can try and take the square of both sides. Yes, only then will I get x square, because right now I am stuck with only x. So next, squaring both sides. When I square both sides, I will also end up removing the square root sign from the right hand side. That will help me with both the cases, which means I will have an x square also, and I won't have the square root sign in the right hand side. So that would be x plus 1 upon x minus 1 the whole square is equal to a plus 3b upon a minus 3b. Let's take the square of x plus 1. That will be x square plus 2x plus 1, and the denominator would be x square minus 2x plus 1, and this is a plus 3b, and in the denominator I have a minus 3b. And now I can again do cross multiply, but let's take common componendo and dividendo. That removes the elements, makes our life easier, right? So using componendo and dividendo, let's see what we get. X square plus 2x plus 1 plus x square minus 2x plus 1 divided by x square plus 2x plus 1. The sign of all elements changes, which means negative x square plus 2x minus 1. This will be equal to a plus 3b plus a minus 3b divided by a plus 3b minus a plus 3b. This gets cancelled and a gets cancelled. Here, negative 2x plus 2x gets cancelled. Negative x square plus x square gets cancelled. Plus 1, negative 1 gets cancelled. So what we have is 2 times x square plus 1, and what we have is 2 times 2x. This is equal to 2 times a upon 2 times 3b. Yes, 2 and 2 gets cancelled, 2 and 2 gets cancelled. Now we can cross multiply. So when I cross multiply, 3b times x square plus 1 is equal to 2x times a. Let's open the bracket. So this is 3bx square plus 3b minus 2ax is equal to 0. That's exactly what they wanted us to prove. 3bx square minus 2ax plus 3b is equal to 0. Hence proved. Very interesting question. It appeared in your board exam as well. That brings me to the last question of this exercise that I solved with you, which is question number 13. Again, an interesting question using properties of proportion. So, using componendo and dividendo, we get x to the power 4 plus 1 plus 2x square upon x to the power 4 plus 1 minus 2x square is equal to 17 plus 8 upon 17 minus 8. I notice this can be written as x square to the power 2 plus 2 times x square multiplied with 1 plus 1 square, which means I am trying to convert this into x square plus 1 the whole square, and the denominator to me looks like x square minus 1 the whole square. Yes, that's correct, and this is 25 upon 17 minus 8, that's 9. So the numerator now is x square plus 1 the whole square, and the denominator is x square minus 1 the whole square, and this is 5 upon 3 the whole square. Next, taking square root of both sides, what we get is taking square root of both sides. What we get is x square plus 1 upon x square minus 1 is equal to 5 upon 3. Next, let's again go ahead and use the componendo and dividendo. So using componendo and dividendo, we get x square plus 1 plus x square minus 1 upon x square plus 1 minus x square plus 1, which will be equal to 5 plus 3 upon 5 minus 3. Negative 1, positive 1, negative x square plus x square. What we have is 2 times x square upon 2 is equal to 8. 5 plus 3, 8. 5 minus 3, that's 2. 2 and 2 gets cancelled. 2, 1, 2, 4. So what we get is x square is equal to 4, which means x is equal to plus minus 2. Let's check if both values work. Yeah, since we are taking the fourth root, or not the fourth root, we are taking the fourth power and the second power. Even if it is negative, it will become positive when we take the fourth power. So the answer is x is equal to plus minus 2. Okay, a longish video. I have solved quite a few questions. I have marked a couple of homework questions here. Hope you like the video. If you have any questions or queries, feel free to write into me. Take care. Bye bye. I'll see you with the next video.